two negative charges, A and B, are placed at the corners of an equilateral triangle. What is the magnitude of the net electric field at point C? We've actually already worked this problem, and I encourage you to go back into the presentation and see it, but there was one wrinkle. We had positive charges. So what's going to change? Let's move him over here and put our solution that we already worked. Okay, see the positive charges here? The only difference is when we add the vectors, here's EB and EA. Since we have negative charges, the vectors will point this way. Okay, they'll be going down, and then the net electric field will be in the down direction. But this is just a mirror image of this. It's a reflection. So all the angles will stay the same. So what we can do is still use our solution. And let me get rid of this. And just remember that we're flipping the direction of the electric field. But we're only asking for the magnitude anyway. So when we take our x components, they still cancel out. You've got one going this way, one going this way. The y components will add. You can see how these two support each other, except instead of going up, they're going down this time. They're each equal to E sine 60 plus E sine 60. The electric field due to each charge is the same because it's the same distance away from point C, and each magnitude of the charge is the same. We then plug in our value for E, which is KQ over R squared. And we also have this radical 3 over 2, which comes from the sine of 60. We add those two together, we get radical 3. And then we actually did a little longer way. We used Pythagoras, where we counted the x direction as 0, and we still get the total electric field is our component in the y direction. So that would be E total is radical 3 KQ over R squared. Now let's see if we can recover our answer from all this moving around. And let's see. Here it is. The answer is B, and with any luck, this will also show B. And yes, it does. So remember the symmetry here. We've basically switched the problem from the one we did in the presentation, had a mirror image, all the angles stay the same, the magnitude will be the same. The only thing that is different is the direction of the electric field. When there are negative charges, the field is down. Positive charges, the field is up.